Hi everyone, we're going to find the solution set for each rational inequality. This is part 7, and we're not going to do each one, we're just doing one, which is this one right here. That means we want this inequality to be bigger than 0. That means we want the graph, when you're looking at the graph, when you're graphing it, we want what part of the graph is on the positive side of y equals 0. So when you're graphing it. I'm going to go ahead and factor this, and you get 3x minus 1 times x plus 1. I'm factoring the numerator over x plus 2 is positive. Now this is a strict inequality because there's not an equal sign. And I'm going to find my zeros by setting my numerator equal to 0. So my zeros, or your x-intercepts, are x equals 1/3, or you could say 1/3 comma 0. I like that better actually. And -1 comma 0. Those are your x-intercepts. And then we also have to find where our vertical asymptotes, that's our vertical lines, and that's where f is undefined. So f is undefined at x equals -2, and that's your vertical asymptote. So we have 3 key points here, or critical values, and the critical values are -2, and I'm doing a little number line, -2, -1, and 1/3. This is your x. So the intervals I want to choose are from -infinity to -2, then from -2 to -1, then from -1 to 1/3, and then from 1/3 to infinity. Alright? I'm going to write down my equation again. It was f of x equals 3x squared plus 2x minus 1 over x plus 2. Alright, and so I'm going to evaluate certain numbers I choose. The numbers I choose were -3, -1.5, 0, and 1. And I evaluate the numbers by plugging them in everywhere there's an x there. So I get -20, 5.5, -1/2, and 4/3. Now we want our values to be positive, strictly speaking, and our positives are here and here. These two are negative, so we don't really need those. So our solution set is x such that x is in between -2 and -1, or x is greater than 1/3. And that's all. Thank you. Have a nice day. Bye-bye.